Hello everyone, today we are going to solve a medium level LeetCode problem of add two numbers. In my previous video of competitive programming, I have explained all these steps that you can follow for solving any competitive programming as well as technical interview questions. In this video, we are going to follow the same steps but with a different example. If you have not watched that video, I'll link that video in the iCard above and in the description below. So without further ado, let's get started. My name is Aditya Shenoy from Brainy, where I make programming simple and fun. The first step of solving any competitive programming problem or any technical interview question is to understand what's the problem. In technical interviews, the interviewers just say that out loud, and in this competitive programming websites, we have this first paragraph. So you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. So this is the problem. Many people after listening to this problem directly jump to the code, which is a wrong practice because we have to understand the assumptions and constraints first, which is exactly our next step. Given the problem, we have to understand all the constraints and all the assumptions before writing the code so that we can handle all the edge cases properly. In competitive programming websites, the assumptions and constraints are mentioned explicitly, but in technical interviews, we have to ask those assumptions and constraints after we get to know about the problem. So a good practice if you are preparing for technical interviews is that you should just read this first paragraph to understand what's the problem, and after reading this you should come up with questions asking about the constraints and assumptions. There are two types of assumptions and constraints. First is related to the data structure and second is related to the values. In this case, we are very lucky that the assumptions are mentioned in the problem statement directly, but it can be the case that the problem statement that our interviewer mentions is you are given two linked lists. So we have to ask assumptions and constraints about the data structure, that is linked list, whether it can be empty, whether it can have just one node. The second type of constraints is the constraints of the values stored in these data structures. And in this case also, we are lucky that it is explicitly mentioned that the values inside this data structure as it represents digits should be non-negative. And non-negative here includes 0 as well, which should make us think about the leading zeros. As this linked list represents a number, numbers can have leading zeros behind it without changing its meaning. So will that happen here? Because that will change our algorithm. So this can be a question to our interviewers, for after which they can say that you may assume that the two numbers do not contain any leading zero except the number 0 itself. So only if the number is 0, we will have a linked list with just one node containing the value 0. In all other cases, it will have the numbers without any leading zeros. So that's a good sign for us. After hearing these constraints, you can come up with some examples, sample inputs and sample outputs like this 243 and 564, which actually represents 342 and 465, as the digits are stored in reverse order of their significance, and the addition will be 7, 0, 1 carried 8. So 807, as you can see here. And if the input is 0, then only we will have 0 at the leading position, which will again have 0. And in both these examples, the number of nodes in the list were equal, but you should come up with some example with two lists with different number of nodes. Still, your algorithm should be able to handle those. And there are no more constraints that I can think of. And in this constraint section also, there is nothing extra mentioned apart from the leading zeros and the digit range and the number of nodes. So now we can go on to the next step, that is the baby approach. The baby approach is the brute force approach, and coming up with the brute force approach is very easy. You just have to think from a baby's point of view, that if you are very young and you are given this problem to solve, so how will you solve? You will most likely do the addition that you learned in the school, that is you will add one digit at a time and then store the carry above it and then do the addition and so on. This baby approach is a brute force approach which traverses all the nodes in the linked list. Before writing the code, we should try to come up with some approach which will be more optimized than the brute force if possible. So that brings us to the next step, that is the manual approach. So currently we have thought from a baby's perspective. Now think of from a grown-up perspective and think in that way. Like if this problem is given to you now, how will you solve it manually without any help of computer? Even in this case, we will be solving it the same way as the brute force. Like we will be adding single digits at a time and then storing the carry. There is no workaround for that. So unfortunately, the baby approach or the brute force approach is the optimized version. And once we have thought about the optimization of the baby approach to the manual approach, we can start writing the code. So we have to traverse the entire list. So first I will do a generic while true. We will add the breaking condition here or in the loop itself later. But first we will cover the generic condition and then we will focus on the edge cases. The parameters here are L1 and L2, which will represent the head of the linked list. So we can directly start adding the values, and the structure of the list node is also mentioned here, that self.val will give us the value stored inside that node. So we can create a variable sum which will have L1.val plus L2.val. As we are thinking about the first node, obviously the carry forward bit is 0 by default, but in this generic approach we have to think of nodes which are in between the linked list so that we can write a generalized loop. So we also have to add a carry, and initially the carry bit will be initialized as 0 and we will get L1 plus L1.val, L2.val plus carry. And this 3 addition might result to a number greater than 10. So we have to again calculate the carry for the next addition and the remainder to be stored in the linked list. And as we are talking about storing the values in the result list, we have to create the result list first, because we have been told that we have to return the sum as a linked list itself. So we will initialize a result with a list node, and here we can see the default value of the list node is 0. So we are initializing that with a 0. And we have to return the head of the node. We cannot use this result node directly in the loop because that will also start traversing as we add more nodes to it, and it will eventually go to the end of the list. And we want to keep track of the head of the resulting list so that we can return that. So instead of manipulating the result node directly, we will keep a separate pointer which will be called as current, and it will initially point to result because that is the only node present. But in the loop, this current pointer will change, but the result will remain the same, so that we can return the result after the loop is over, like this. So now as we have the sum of these 3 values, we can store the remainder of this value with respect to 10 in the current node of the list, and we can also calculate the quotient with respect to 10 again and store that in 10. In Python we can do that in single go. So I'll do carry and current.val equal to div mod. So division will return us the quotient and modulus will return us the remainder. So div mod will return us that. We have to do division and mod of sum with respect to 10. So this will give us the carry and the current.val. Now at this stage we have processed the current inputs and outputs value, so we can move all the pointers to the next pointer. So we will do that now. L1 equal to L1.next, L2 equal to L2.next, and for current node, so there is no extra node added by default, so we have to add that explicitly. So we will do that explicitly by doing current.next by initializing a different node with the default value of 0 and then moving the pointer of current to current.next. Now this is a generic code, but this code will surely fail on the edge cases where the lists are ending or some other edge cases. So let's try to see like what are the edge cases here. So if we are given this problem 2, 4, 3 and 5, 6, 4, for the first iteration we will have 2, 5 and carry as 0. So we will get 7 as a total. Carry will be having again 0 and current.val will have the 7 value. Now L1 will go to this 4 node, L2 will go to the 6 node. Currents next will have a different node with the initial value of 0 and current will move to here. So this iteration looks good. In the next iteration again 4 and 6 will be added with the carry again 0. So we will get 10 this time, and the quotient and remainder of 10 with 10 will be carry will be 1 and current.value will be 0. So 0 we are setting that and carry we are setting 1. Again we are going L1 is L1.next, L2 is L2.next, and we are initializing this node with the 0 value and moving the pointer of current to this node. Now at this point we are at the end of the list of the inputs, so we might see something in this iteration or the next iteration. So L1.val is 3, 4 and carry is 1 this time. So 3, 4, 1 is 8. The quotient and remainder are 0 and current.val will be set as 8. L1 will go to next, which is none here. L2 is L2.next, which is again none. And current.next we are setting up a node with the 0 value, which is a problem because we have exhausted the list and we have already got the answer. So before setting this we have found an edge case that we should only create a separate node if there are some inputs, and by inputs I mean these three values. There should be some value in L1, L2 or carry. So we can fix that by checking whether L1 exists or L2 exists or carry exists. Any one of them, even if they exist, we can create this node and move the pointer to the next node. So calling the value property of a none value will throw an error. So we have to also check with the same condition. If any of these does not exist, we can simply break from this loop and return the result. So for this example, we have checked for all the edge cases, but remember this example has both the linked list inputs with equal nodes. So we also have to verify this code for inputs where there are unequal number of nodes in the input linked list. So by continuing this example ahead, if we have just one node for the list 1 and not list 2, what will happen in that case? So in that case, L1 will not be none. This condition will become true and the next node will be created and the loop will not break, and we will go to this part again. L1.val will have some value. In this case, as one of the list had some value and the other did not have any node, so we can replace this none value with 0 in that case. So we will change this to support that. So if L1.val, if L1, L0. So this is a ternary operator. This is a ternary operator here, which says that L1.val take the value of L1 if there is some node in L1 pointer, else take a default value of 0. So this is for the case where L2 has a node, extra node, but L1 does not have. Similarly, we can do the same thing when L1 has an extra node but L2 does not have. So I'll just write that. L2.val if L2 L0, and at the end we have to add a carry, and this condition will also work For example, if this had been say 9 instead of 3, we will get 9 plus 4 13. So we will store the 3 here and we will have a 1 here. So that's why we have also included carry in this condition, because even if there are no nodes here but we have a carry, we should also add a different node so that we can also take an account of that carry thing. So this line of the code is now looking good. Similar to how we have changed this l1.val, whenever we are referencing a attribute with the dot operator anywhere in this code, for example this current.val, so we have to think whether this current will have a none value. That cannot be the case, because before starting this loop, either we have a node here or a node here. So the current value will never be none in this case. So we are good with that. Going on to the next line, we have l1.next, but we have just seen that l1 or l2 can be none or both can be none. So instead of saying l1.next always, which will throw an error at the edge cases, we can do l1.next if l1 else none. Similar to this, if l2 else none. So only take the next value if the current value exists, else keep that value as none. So with this change, I think the code looks good and can handle all the edge cases that we have. So we can try running this code. So it has accepted our input cases that are shown here. We have to submit this code for testing with the hidden test cases as well. And as you can see, our code has been successfully submitted with all the test cases getting passed. After coming up with the manual approach code, you should also analyze the time complexity and the space complexity of your code. So in our case, the loop will traverse all the nodes in the input linked list. So if there are n nodes in our input, the loop will go on at most for n times. So our time complexity is O of n here. There is no nested loops as such. And for the space complexity, apart from the result node, we are not storing anything extra apart from this carry bit. And this carry will always be a single integer, no matter what size the input list is. So we can say that our space complexity of this code is O of 1, that is constant. So after submitting an optimized code, we go to the next step, that is manually hard approach. So even if you have submitted an optimized code, there can be a case where you can optimize it more. At this stage, the interviewers might give you a hint by asking you whether there is more optimization possible in this case, and you should think about it in a way that the data structure in the input, if they are very long, if the data structure is very huge, for example, if as per the constraint, if we test this limit of say 100 nodes, how will you solve that manually? Manually solving a hard approach. If there is an optimization possible, your brain most likely will try to find the optimized way to solve that problem manually. So if we are given this list with 100 nodes and 100 nodes, how will you solve that? Will you solve the problem with the same approach or with some optimization? Unfortunately, in this case also, we don't see any more optimization, because in any case, in any large linked list, we still have to go digit by digit and add the numbers. There is no any other workaround for this. So we can safely say that this is the optimized approach. In this way, we have solved successfully the medium problem of LeetCode, that is add two numbers. And don't worry if you are just a beginner and you are struggling to come up with this solution on your own. That requires a lot of practice. And when you are practicing at the start, you can try to think of the optimized code on your own as much as you can. But if you are struggling with that, even after thinking for some time, you can always refer to the solutions tab or discussion tab here. And instead of just copy pasting the code just for the sake of submitting, you should go through the code and the description mentioned here to understand what was the reason why they chose to do the things this way and not the other way. So once you start reading the solution and trying to familiarize with all the algorithms optimization, you will find similar patterns in more problems that you will be solving. So don't hesitate to look into the solutions tab. It is for your learning only, and with some practice and the steps mentioned in this video of the systematic approach, you will be able to solve any competitive programming problems or technical interview problems. If you found this video useful, please click that like button. Comment down below any thoughts that you have about these steps of the systematic approach. Share this video with your friends. You can connect to me via LinkedIn, whose link is in the description. And there will be some videos on the screen right now which you can watch next. And I will see you in the next video.